All right, friends and neighbors, welcome back to another networking video. This time what we're going to do is a scenario for access control lists. So let's go ahead and get started. We are Camtasia-ing, right? So we're going to create just a couple of networks here, and the goal is to see if we can figure out how to control traffic going from certain networks to certain other networks. So I guess we need some hosts here then, or at least one host in each network. There we go. And maybe we'll do some connections now. Connect PC. And I like using the low numbered ports for the PCs and the high numbered ports for the routers. So we'll go from here and then to here, 23 maybe, and we'll do 24. I also I have a convention that I like to use that says, well, I'll put the lower numbered router ports on the left hand side and the higher numbered router ports on the right. There we go. And then last but not least, our PC over here. So what I think I'll do, oops, suppose we had to connect that. So what I think we'll do is we'll maybe make this the 192.168.1.0 network /24 just to make life easy for this video. Oops, 2.0/24, and then 192.168.3.0/24. Okay, that looks good. Oops. Very good. And now I suppose we ought to do our PCs. So this will be the one net. We'll put we'll make this guy 1.0. Oops. And I have another convention that I like putting the that's not going to work. I like putting the 254s on the right hand side and the 253s on the left, and we'll see what that looks like here in a second. Now for the routers, I like to do the CLI because no, I don't want the initial configuration dialog, because that just gives us practice on a CLI. So I'm going to do int f0/0. Try that again. There we go. And IP address 192.168.1.254. Do a no shut, and then this is what I mean. We'll go int f0/1. Now this is going to be the 2 network, so we're going to have 2 router interfaces there, and we'll put the 253 on the right or on the left. And I sort of always do that. What did I do? Whoops. Forgot the command argument. Happens sometimes when you're trying to go quick. Okay, we'll do this router. Nope. And we've got now the same thing here, right? This router is got 2 interfaces, and if I stuck to my convention, then this one would be 192.168.2.254. And int f0/1. 192.168.3.253. Now I could call it 254, it's the end, but you know, I'll just sort of stick to the way that I've been doing things. And that way I sort of always know where everybody is. All right, we'll finish with our PC, or PCs. Now, the middle PC, right, it's sitting in between 2 routers, and so you could pick either 253 or 254 for the default gateway. If we were doing a lot of stuff, we would think about where most of the traffic was going to go. So we didn't have a lot of ICMP redirects, but in this particular case, it doesn't really matter. And so we'll just sort of pick a convention of using all the 254s as the, well, I guess it doesn't really matter. It's just this one that's affected by it. This host, of course, whoops. Click on the wrong guy? No, okay. This host has really one choice, right? 3.253 for its gateway. Okay. Now, before we start doing ACLs, right, we have to do some stuff with the routing, right? Because we've got 3 networks here, we only have 2 routers, so of course we need to do our IP route statements. So this router knows about the 1 and the 2 networks, does not know about the 3 network. And so we have to get to the 3 network via our neighbor router that we can touch, so somebody on the 2 net, and then the router's interface that we're going to use to get there. Oops. There we go. And of course we have this other router, and this one knows about the 2 and the 3 networks but not the 1 network, and so we need to get to, I suppose we ought to add the IP route command, We need to get to the 1 network, and we're going to go the other way, so we need 2.253 to get there. Do that command, and then we'll do a quick look at the routing table. Right. And there we have all 3 of the routes, and if it works, then we ought to be able to say, now remember that the first one will be delayed because everybody's got to update their ARP tables. But let's try the 2 PC on the 2 network first. Give this a second. There we go, success. And then we'll try to reach the 1 network. And we've got the same issue. Uh-oh, there we go. All right, so remember that those timeouts there are typically the routers trying to find the hosts. Okay, good. So all of my routing works. Now let's say, what's our scenario here? Right now, everybody can get to everybody else. And let's say that we were trying to control traffic a little bit here on the networks. And I wanted to, well, we'll just pick a scenario. So let's say that we are going to allow traffic from 192.168.1.0 to go to 192.168 3.0. Okay, but we want to deny 192.168 2.0 from going to 192.168 3.0. And so all that we're going to do is think through the possibilities here. So that's our first scenario. Okay, so now we're going to come over here to our router, and we're going to set up some access control lists. Now, in full disclosure here, right, there's a couple of ways that we could do this. I could just say permit the 1 network going to the 3 network. I could say that. And that would deny traffic going from the 2 net to the 3 net for the simple reason that we have an implicit deny all. But we want to, we want to sort of lay the whole thing out here. So I'm going to do an IP access list. Actually, just an access list. And we'll do access list. Now, for today, we'll also do extended access lists. So let's do the source and the destination. Access list 101. Now I could pick any number here, right? I could do access list 167. Now, if we take a look at our objects here as we go along in an extended access list, we'll just do it sort of step by step. Because in an extended access list, we're looking at both source and destination criteria. Standard access lists typically just look at source criteria, match criteria, that's what we're talking about. And let's start with the first one, the first deny. So we're going to stop the 2-net from getting to the 3 network. So let's do the deny part. And then what's next? Well, we are going to say, now it's this, this sort of commands here. I should have done a space bar for a little bit of space. And we're talking about IP traffic. And because we're going to do a particular network, if I wanted to, sometimes what you do is the any command if you've done the denies. So maybe what we'll do is we'll do this a couple of ways so we can see how we get through this. So if I say the source address 192.168, we're going to deny the 2 network, the 2.0, and we can't forget our mask. Now what's the next thing that we would do? Well, I would specify my destination. Now I could say any destination, but I want to be a little careful here. So we're going to be very specific, and we're going to say, let's make it wider. It will. Okay. Remember that we're trying to do the 2-net to the 3-net. So we're going to, this is the destination that we have in mind. And we'll do our wildcard bits. Okay, so that's our 2. Now we have not just one set of match criteria. We got the source and destination that we're looking at, and then what we do. So we could at this point be done, and I think we will be. All right, and so what I'm going to do is, well, let's remind ourselves that currently this access list isn't doing anything, right? It's just a container. And so right now what we need to do is apply it to an interface and a direction. Now, where would we do that? Well, if I'm trying to stop traffic from the 2-net to the 3-net, I could block it right there or right there. If I block it right here, the router doesn't have to do any routing first and then do an access list. And if I did it right here, the router would have to route it first and then do the access list. So that's a little inefficient, but what we're going to do is, because it's a little weird to have the 2-net being denied while you're talking to a router on the 2-net, why don't we go ahead and do it here on this interface so we can sort of see what's happening there. So I'm going to go to int f0/1, and I'm going to do IP access group. And what did I pick? 167. And remember that this is going into the 3-net, but out of that particular interface. So out. Okay. And so we'll just quickly see what that looks like now. Here we've got the access list applied, and here's our access. Remember that we're denying the 2-net going to the 3-net. And let's see if that works. So we're going to go here, whoops, and we're going to try to ping. Now remember that before the pings worked, and we'll go to 3.1. Ooh, it doesn't work. And what this router is telling us is that it does not know how to get to this particular destination. But that's not really the case. What really happened is that that traffic got filtered. But the way that we've done this, we've sort of created a problem for ourselves in that when I now ping from the 1-net, that was not allowed. Okay, so what we're going to do is we got to fix our access list. And I'll show you 2 ways to do it, but then we'll settle on the very specific way. So we're working with access list 167. Now I could say permit IP. Remember, and I'll do your question marks for you. We could say IP, and then what do we do? Well, I could say any to any, right? And then I could be done. And what that does is it says, well, we already had a deny, and as long as I denied that traffic, everything else is okay. So that says any source to any destination. But what I really want to do is we're going to be specific. So I'm going to say that it's okay for the one network, okay, to get to the 3 network. There we go. And there is, this allows us to get from this particular network to this particular network. So we're going to do that. Now, one of the things we've got to be a little careful of, and I'm going to check it here, is that when you're changing access lists on the router, sometimes the router wipes out what you did before. So let's make sure that we have everything in our access list. And we do, and the access list is still applied. So let's go back over here to our hosts. Now this one should still not work. And this one should work now. Hey, huzzah. Okay. So that works really, really nicely. But what happens if the network is a little bit bigger? So let's add on to our network here. And we'll go ahead and connect this guy in. And this is one of the reasons I like to stick to a convention, because it lets me, well, it helps me remember what I was doing and how my topology is set up. We'll add another PC right here. And so the question is now, this ACL is right in the middle of this topology, right? And what is the impact of having that ACL in the middle of this topology? Okay. Now we're going to create the 4net here. So let's do that. We'll just make a label over here. 4.0/24. And of course this will be 4.1. Oops, 4.1. And the gateway, 192.168.4.253. Okay. Now our router, quickly. Now we got a little bit of work to do here, because we've now added another network. So we got to update our routing statements, right? So first we'll do our interfaces, int f0/0. This is on the 3 network, so 192.168.3.254. Again, in keeping with my convention. And of course, now we get to see more of this. Whoops, did it again. We get to see more of the difference between the subnet masks and the wildcard masks. And let's go to int f0/1. This will be 4.253. There we go. And I will do our IP route statements. Now this is a sort of a helpful review if you haven't done IP route statements in a little while. Remember that this router, now being all the way over here, knows about the 3 and the 4, but not the 1 and the 2. So we need to get to the 1 network and the 2 network. But how do we get there? Well, this is the 3 network. We're connected to this. It has to be a neighbor, and it has to be a neighbor we can get to. So this interface right here. So 3.253, if I remember right. Now, how do we get to the 2 network? Well, it turns out we have to get to it from a neighbor that we can touch. Turns out that the same exact router interface. Okay. And then we will take a look at this poor router here. If I can get the CLI to come back to me. Come back to me. There we go. We need to get all the IP route statements here too. IP route. Now the thing that we don't know about now, of course, is the one we just added, which is the 4 network. And how do we get there? Well, this router knows about the 1 and the 2 networks. The router that we use to get there is this interface right here. So we're talking about this router getting to the 4 network. We need this interface right here, and that is 2.254, if I recall correctly. There we go. And that would leave this router in the middle. And we need to get to the 4 network. And how would we get there? Well, we would get to it via this interface right here, which should be 3.254. Now this is a little tricky all of a sudden because the router number 1 here has got the ACLs. So maybe we'll put a label right here. This is where my ACLs are. Right? And so how do I do this testing now with my ACLs? Remember that the 2 net is prevented from getting to here. So how do I test connectivity to the 4 network? Okay, that's a problem. Well, it turns out that we can go right back in here and we can say access list 167 permit IP. Now, if we were doing anything else, if we were worried about TCP or ICMP or things like that, we might use those specific protocols, right? But we're just trying to do an example here. So now I want to get, I'm going to permit 192.168.2.0 network. And let's make our router interface a little bit bigger again. Now our mask, wildcard mask. There we have it. And where do we want to allow ourselves to go? Well, we're going to go to the 4 network. And there we go. And again, I could add more stuff, but I think we're done here. So now if we actually we'll do this. Oops. Oh, come on. There we go. And we can see our rules. We can even see how much traffic has been matched against it. So we're denying the 2 net going to the 3 net, but we just turned around and said the 2 net's allowed to go to the 4 network. Let's see if that works. So let's ping 4.1. Now the delay, again, we have to do the the ARP table updates and all of that, but hopefully this gets through. Notice that the router is not saying destination unreachable, so it's getting out there somewhere. Hey, look at that. Look at that. Okay, well, what about this guy? Can this guy get to the 4 network? The answer is absolutely no. Now, take a look at this, too. This was from 2.254. Now, I'm way over here. And this went through the first router all the way to 2.254, of course, where our ACLs are. And so this router said, you can't get there. So what would we have to do? Well, we could add an access list, or we could add to our access list that says, well, I also want the 1 net to be able to get to the 4 net. So I might do this, right like that. Okay, and then we'll go right back over here, and we'll try it again. And all of a sudden it works. Okay, so this is an example of how you can control traffic. We prevented this particular network from going to the 3 network, but then we said, well, even if it's not allowed to go to this destination, right? This is the guy that we were worried about. Whoops. Can I change the size of that? If this is the set of rules that we were worried about, what we ended up doing was we said, well, I can permit 192.168.2.0 after that, I could say, well, it's okay to go to the 4 network. So you really can sort of mix and match your rules and decide where your traffic is going and where you want to stop it. And I can control this traffic and stop it anywhere I want to, especially for the deny, right? Once even if I said any traffic is allowed to go anywhere, because of that implicit deny all, or because of the power of the deny statements, at any point along the way, if I put in a deny statement and the match criteria matches that deny, that traffic is killed off. So we'll do one more example here. On this router, what I will say is, now we know that the 1 network is allowed to go to the 4 network. But let's do this. Let's go access list 111, deny. We're gonna stop the 4 network traffic from coming back. So we're gonna say deny 4.0. Now it's the first criteria, so it's the source criteria. So I have to think about that. I have to think about where my test is going to happen. And what are we doing? We're going to deny the 4 network from getting to the 1 network. And we have our match criteria. All right. See if I got all my zeros in there. That looks good. Now, whoops, there we go. I forgot one of my keywords. There we go. All right. Now, we know because of the implicit deny all that this would kill off everything anyway. So let's do this too. Let's do any. And what that does is, as long as it's not denied, it'll be permitted. Now, I haven't applied it yet. It's not applied to an interface and direction. So let me do this. All right, so we know that, right, so we know this works. And I just took a look at my ACL here, and I realized that I made an oops, right? I got to do this. Well, actually, let's actually do this first. We got to permit, right? So we got to permit any. There we go. So let's make sure that we like the way this looks. So we have our, okay, we got to fix this now. Whoops. So that's exactly what I was talking about with the editing here of access lists. So let's do this. We'll do them in order. So we're going to deny the 4net, and then we're going to permit. Now let's take a look. All right, that looks better. Okay, we know that it works right now, but let's apply this. Well, where would you apply it? Well, what if we applied it, and we'll minimize you for a sec. We're going to apply it right here because the 4 network is the source. So it has to be either into this interface or out of this particular interface. And just for fun, we'll do it on the outgoing side. So we're going to go int f0/0, IP access group. What was I using? 111 out, right? It's got to be coming out of that interface because that's the only place that we would have the 4net as a source. And let's see if that did the traffic in. So it's going out, but it can't get back. So what ends up happening now is, we'll move on this off to the side. Right, we're just, so it's failing. So it goes out, goes all the way out, but then it can't get back. It gets killed off right here on the way into this particular router. And we can see that it failed. Well, there you go, friends and neighbors. There's another networking video. Hopefully this was a little review of not only static routing, but also a little bit of new stuff on how to do some some extended ACLs, but also using ACLs to control traffic between different networks. Thanks very much for watching. Thanks for listening. May your packets always reach their destinations. And hey, remember, this is networking. You can do this.